Welcome! Today, we'll learn how to find the domain of a logarithmic function where the base itself is a function of x. Specifically, we're looking at functions of the form f of x equals the logarithm base q of x of p of x. To find the domain of this function, we need to satisfy three conditions based on the definition of logarithms. First, the argument of the logarithm p of x must be strictly positive. You can only take the logarithm of a positive number. Second, the base of the logarithm, q of x, must also be strictly positive. The base of a logarithm must be a positive real number. And third, the base q of x cannot be equal to 1. A logarithm with base 1 is undefined. Therefore, the domain of our function f of x is the set of all x values that satisfy all three of these conditions simultaneously. Let's work through an example to see how this works. Suppose we want to find the domain of the function f of x equals the logarithm base x plus 2 of x minus 1. Now, we apply our three conditions. Condition 1, the argument x minus 1 must be greater than 0. Solving this inequality gives us x must be greater than 1. Condition 2, the base x plus 2 must be greater than 0. Solving this gives us x must be greater than negative 2. Condition 3, the base x plus 2 must not be equal to 1. Solving this gives us x must not be equal to negative 1. Now, we need to combine all these conditions. X must be greater than 1, x must be greater than negative 2, and x must not be equal to negative 1. Let's visualize this on a number line. First, x must be greater than 1. We represent this with an open circle at 1 and shading to the right. Second, x must be greater than negative 2. We show this with an open circle at negative 2 and shading to the right. Third, x cannot be negative 1. We mark this with an open circle or an x at negative 1. The domain is the region where all conditions overlap. Looking at the number line, we see that the intersection of x greater than 1 and x greater than negative 2 is simply x greater than 1. The condition x is not equal to negative 1 is automatically satisfied if x is greater than 1. So, the final domain for our example function is all x values strictly greater than 1. In summary, finding the domain of a logarithm with a variable base involves checking three key conditions. The argument must be positive, the base must be positive, and the base must not equal 1. By solving these inequalities and finding their intersection, you can determine the function's domain. Thank you for watching.